About me, my name is Lázaro Nixon. I don't have many social medias, but you can follow me on Twitter at Lázaro Nixon. I usually post things about Ruby there, about my open source jams, about things that I feel interested in, and mostly I retweet things that I think it's interesting. So follow me on Twitter. My background, I'm a Brazilian, so this is why this talk is not in Spanish, because I can speak Spanish. I can understand a little bit, so if you are free to make questions in Spanish, I believe some fellows can help me with that, to translate the question to me. But that's it. Also, we have many Brazilians here at the company at this moment. I believe we are most than 10 people here. So I thought it was important to mention that. I'm a senior backend developer here at Koombea. I was hired as a backend developer. Mostly, now I'm working with Rails. But when I joined the company, I started with Elixir. I worked 1 year with Elixir. And also, before I joined Koombea, I worked with Java too. So I'm a Java developer too. So my background is Java, Ruby on Rails, and Elixir a little bit. Yeah, this is the next topic. I like to contribute to open source. So I have some libraries that I create and I like to share. Sometimes I see something that I think that could be better or doesn't exist or doesn't fit to what I want to develop. So I usually contribute to open source. I have some open source libraries. So the first one that has been very popular lately is Authentication Zero. It's a library for authentication, but different from Device and the others. It generates code and put in your application. And so you are responsible for the security, but it's also, you can customize this authentication the way you want. Oh. Also, Administration Zero. It's also on this field of generate code. So instead of you have active admin, it generates an admin panel code for you using like scaffolds, the scaffold command. So you have a admin panel. Also, SASS Zero. This is a library for work with CSS, but like with Tailwind. So for each Tailwind variable, I create a variable on CSS. So it's a mix of these two roles. Documentation Zero, it's generate documentation. Tricks extension. We have that action text library, right, on Rails. So this tricks extension brings more features to that. So it adds more features. Also, in the past, I create this library, React Native Turbolinks, that integrates Turbolinks with React Native. So it was an effort to you create mobile applications using Rails and Turbolinks. Active persistence, that is a Java library. You know, when I started with Java, then I migrated to Rails. Then I had to work with Java again, but I didn't have what Java had, what Rails had, right? So it's like an active record for Java, something like that. So I joined Koombea 2 years ago, almost. So I've been here for 2 years, almost. That's it. I'm backend developer here. And the agenda. So we'll talk about Ruby and about performance improvements. So we'll talk about the production-ready YJIT, object shapes, regasp matching algorithm, new features, and we'll talk about WebAssembly, syntax to suggest, error highlight, and about the language, we'll talk about the data class, anonymous arguments, passing anonymous arguments, fine using pattern matching. So let's talk about the Ruby programming language. It was a programming language created in 1995 in Japan by Yoshiro Matsumoto. Most of you know, Ruby is that kind of language like nowadays, Dart. So people usually know Dart to work with Flutter. So for me, it's a kind of advantage because you have a language to work that mostly is to improve a framework. So I think it's an advantage. So mostly of people who knows Ruby nowadays is to program with Rails. The Ruby version is released early, usually in Christmas. So the first thing that I that I do on Christmas morning is to see the new Ruby version. No, I'm kidding. I don't do that. So Ruby has the main feature to be optimized to happiness for programmers. So it's not a language optimized for performance or stuff like that. Actually, we had a conversation like that on the chat few days ago about Ruby is not optimized for performance, but for programmer happiness and to be more maintainable and stuff like that. And I like that idea, to be honest with you. I was never that kind of person, like a computer science person. So I like to Ruby because of it. So it's also the main language used here at Koombea. I mean, to work with backend development. Also, we have mobile, so they use Swift and Kotlin most of the time. Also, we have hybrid programming nowadays here in Koombea. So we have a lot of JavaScript, sadly, unfortunately. So if you don't know that, Ruby 2.7 will hit the end of life in March. So update it. So you need to upgrade your Ruby version because you might be in trouble if you don't do that. You can get problems with security and other things. So let's start with the performance improvements. So let's start with YJIT Compiler. So the Ruby 3.2 brings, I believe this is the main feature with Ruby 3.2. It had this performance improvement, and it brings with the YJIT compiler. So let's see what it is. So what is YJIT? So it's acronyms with yet another Ruby JIT, because we have another JIT compilers in Ruby. So we have mJIT, TenderJIT, and others for other people. But what is JIT? So this is the question that I made to myself. So it's acronyms for just-in-time compiler. Okay, but what is a just-time compiler? Well, do you know what a compiler is, right? So I'm doing this question because I didn't have a computer science degree. I went to the college, but it wasn't my, I didn't have this class like compilers and interpreters. So I didn't see that in my college, I believe. So I believe most of you don't too. So Ruby is interpreted language, isn't it? So most of you might think that Ruby is a interpreted language. Sometimes. So is Ruby interpreted or compiled? So before we talk about the YJIT compiler, I would like to introduce these concepts about Ruby, how Ruby is interpreted and then compiled and everything. So what is the compiler process of Ruby? So first we have that kind of language. They are ahead of time compiled languages. So I had the opportunity to work with Delphi 7, Borland Delphi 7. So you have an application, the IDE, and usually we have a button like that. So you program and you click on the play button and your program is compiled. You have your code is analyzed. Everything happens ahead of time. So the result is something like that. You have executables for your system. So this is what is a ahead of time compiled languages. You can see that with language like C, C++. So when you write C code, you write your code on a text editor, and then you have a compiler. Mostly we use GCC to compile this file. Delphi that generates executables for Windows, mostly. Visual Basic, the same. C# when you are using .NET framework, so you have an executable. Java also, because when you compile Java, you have a jar file. So this is a compiled file that will be interpreted by a virtual machine, but we'll talk about it later. And we have Elixir. Elixir is also a ahead of time compiled language, because the first time when you run your Elixir application, it is compiled. But it's different from Java and others because you only have the files that you have changed compiled. So you don't have to compile all the files every time you run a project. And we have the interpreted languages. So usually interpreted languages, we have a text editor. We don't need an IDE. That is a good thing. So you write your code there, and then you have an interpreter. In this case here, the Ruby is the interpreter, and the example.rb is the file. So this code will be interpreted by the Ruby interpreter. So examples of interpreted languages are Ruby, Python, PHP, Perl, JavaScript. So those languages called scripting languages. So they are interpreted most of the case. I mean, it should be interpreted, at least at the beginning. So how Ruby is executed? So it's very important. So we have your Ruby code. So at this moment, it's just a text file. So this code is tokenized. So when you have these tokens, you'll have this token parsed by the parser that generates a thing that is called AST, the abstract syntax tree. And then it is interpreted by the Ruby interpreter. So if you are on Windows, you should have a ruby.exe to interpret your syntax tree. So on the next slides, I will show you how is each these phases here, right? So this is the Ruby code. So you have 18 plus 24. So when you send it to the tokenizer, you'll have something like that. So you have like, I believe it's the, I believe it's the line number, something like that. And what kind of this string is? So it's an integer, it's a separator, it's an operator, again, separator, it's an integer. So you have these tokens. And so after you have, at this moment, it's just like an array of tokens, right? Then the code is parsed. So it's another phase. So we'll have this thing called abstract tree. So you have something like that. So binary, and now you have more information here. And it's called abstract syntax tree. You might be aware of this concept if you work with a Rubocop rule, if you already create a Rubocop rule, or if you already work with Nokogiri. So in Nokogiri, you have the nodes. Each node represents HTML tag or something like that, and you iterate over these nodes and do whatever you want. So the abstract syntax tree is that. So your code is translated to nodes that your interpreter can interpret. Okay, so we have the Ruby code. It's tokenized, it's parsed, and it is interpreted. Okay. Yeah, it would be nice if it was 10 years ago, because it was the process that Ruby 1.8 had. So it was how it was interpreted at that time. But after Ruby 1.9, it was introduced a new concept. So after your code is parsed, it is sent to a compiler. So what this word compiler means? The compiler is the process of translate your code to another thing, to another kind of executable. So when it's passed for the compiler, we'll have something called bytecode. Yeah, it's the same bytecode like Java. And this bytecode is interpreted by a virtual machine. The Ruby virtual machine is called YARV, YARV, and the acronym is yet another virtual machine. And after so the virtual machine interprets this bytecode, and the code is interpreted. This is how the YARV bytecode looks like. So for that example, you have the 18, 24, and you have the up to plus, and then you leave. So why this compiler? Basically because it's faster, and it is more standardized, let's say that. So it's better for future releases if you have a virtual machine doing that. So the virtual machine, it works step by step. So first it reads this line, so then it executes this line. So after the other line, up plus, then leave. So how it works. So, but what is a YJIT compiler? So on Ruby, actually, I don't know what's Ruby. It was introduced, but then we have this YJIT compiler. So what the YJIT compiler is that for the most called methods, it will be translated direct for machine code. Okay, so it will want this, it won't be interpreted, but it will be translated direct for machine code. In this case, assembly most of the time. But so it's quite fast. So you have the most called methods or pieces of code that you have in your application, and it will be translated for machine code. So, for example, if you have the new processors of Apple, like the M1, M2, so this code will be compiled directly for ARM instructions. So then it's sent for the CPU. Performance improvements. So in Ruby, we have two YJIT compilers nowadays. We have the MJIT. So it generates C code for the most called methods. So it doesn't generate the code for that platform in a specific, but it generates, it is interpreted by a C interpreter, something like that. So unfortunately, it didn't have significant performance with Rails. At first, it was written in C, and on Ruby 3.2, it was re-implemented in Ruby. And we have the YJIT that generates native machine code assembly for the most called pieces of code. So it has two advantages from the MJIT. So it's able to translate pieces of code, and it's translated direct for the machine code, not for C extension. So it was an effort for Shopify and GitHub. We focus if the performance with the Rails applications in specific. This is the advantage of we have a Ruby that works only with Rails. So at first it was written in C, and on Ruby 3.2 it was implemented in Rust because it was easier to implement, I think. So this is our benchmark. There are the benchmarks that we have. So as you can see here, Node.jit is the blue one and YJIT is the yellow. So we had some improvements with Active Record and other libraries. It had an overall of 41%. I mean, then they interpreted C Ruby. So you can see some people saying that, like on Shopify, they had 10% of speedups. So Active Record and others. So they are using YJIT. So we have this other guy telling that after he updated for Ruby 3.2, their test time was dropped from 44 seconds to 5 seconds. Also in this course, there is a Rails application too. We have an improvement in the pages around 32%, 34% with Ruby 3.2 and YJIT. So how do you enable it in your Rails application? It's not enabled by default, actually. So you can use this environment variable, Ruby opt, and set YJIT. And I recommend also you try this tag with gmalloc. It might improve your memory allocation. That's it. So if you want to try YJIT in your application, you must do that and see if you have some performance gain. Another thing that was introduced on Ruby 2.2 are object shapes. What is that? The shapes represent properties about the object and the order in which the properties were set. So when we are talking about properties, mostly we're talking about instance variables. So it means that if you have a class with the instance variables in the same order, and you call this, you instantiate this class many times, you'll have a performance gain because you'll have a kind of cache of this class. So each time an instance variable is set on an object, it changes the object's shape. The idea of object shape can then be used as a cache key for inline caches. Any object that sets the same instance variable in the same order can benefit from the shape. So if you have the variables, in a constructor in the same order, so you have this performance gain. This is especially useful in cases where you are many subclasses of some other classes like active record. So what changed? Ruby already had this object shape, but what happened is that on the past it only had this cache for the same class. So you have like subclasses, you will lose this gain performance. Okay. So for example, here's an example. So we have the class A and we have the class B that extends the class A, right? And then we call the class A and the class B. So here, so it starts with shape ID 0. The 0 is just a number. So it transitions for ID 1. So if we call if we instantiate the class A again, we'll have a cache. So we will have a performance gain. But what happened in the past is that if you instantiate the B class, you wouldn't have this performance improvement. So now with Ruby 3.2, here the transaction shape is 0, but at this moment, we'll have some cache gain here. So we have some improvements in the performance here. So when you call this method, it calls this. So here you have a cache. So it doesn't mean nothing for you in your databases development. So you won't have to do nothing with replication, but it's real important on frameworks like Rails. So here they are changing the order of the instance variables to have more gains of performance on Rails. Also, we have this regast matching algorithm that was optimized. So on Ruby 3.1, it was 10 seconds, and Ruby 3.2, this regast was 0.03 seconds. So it's a huge performance gain for complex matching regast. Sorry. Another thing was, if your code attempts to match a possible inefficient regast against an untraceable input, an attacker may exploit it for efficient denial of service. So it means if you make a field public for your user, maybe to enter a regast in your application, I don't recommend to do that because it's it's not secure. But if you do that, you may have secure problems. With Ruby 3.2, you will still have these problems, but but I mean, it's harder to have these security issues. So it might prevent DDoS, denial of service of attacks, but it should prevent, but I don't recommend you to make these inputs public. As a fallback measure, timeout feature. Oops. So as a fallback measure, they introduce a timeout feature for regast matches. So you can set something like timeout. So if it takes so long, so the regast is is finished and you have an exception is raised. So we'll talk about the new features. So we have WebAssembly. Ruby now supports WebAssembly. What's that? Okay. Someone was. So Ruby now supports WebAssembly. So it means that you can run Ruby on browser. So WebAssembly is a binary instruction format for a stack-based virtual machine. WASM is designed as a portable compilation target for program languages, enable deployment on the web for client and server application. Some people say that it's the future because you won't need JavaScript anymore to work on browsers, to be interpreted on browsers, because the browser will be able to interpret any language. And also you can embed this application in the browser itself, something like that. So it might replace Docker or something in the future, maybe. It's a very interesting topic. So basically, you can do that. So you import this script, so you have the Ruby in your browser. So when you put reload role, you have a real role in your console. Pretty interesting. Syntax suggest. So this syntax suggest gem has been integrated into Ruby and points out missing or extra ends in your code. This functionality was previous in a gem called deadEnd, but it was merged in Ruby itself. So now, as you can see here, this is wrong because it's together. So it's warning you about an unmatched end here. Error highlight. So the built-in error highlight gem now highlights the relevant arguments for type error and argument errors. So we will have this this dash in your error message. Also, we have some improvements on YARV. YARV, if you don't know, is that console of Ruby that you can run your Ruby there. You can test it if you want. So just open your terminal and type YARV. So the debug gem integration commands have been added. So debug, break, catch, next, delete, step, continue, finish, backtrace, and info. So it means that you don't need the debug gem in your application anymore. Actually, you still need it, but I'll talk about it later. They work even if you don't have it in the debug in your gem file. So a few days ago, I talked about it. So, well, if you have this integrated with Ruby, so can we remove that from the gen file, from the Rails gen file? So I asked that question in the Discord channel, Rails Discord channel. So since Ruby 2.3 has integrated, can we stop recommending debug gem? So Rafael França answered that it's a different kind of debugger. It's called ERPL, and so it has some limitations. So we can use that. We still need a new one. So I went to check that, and it was true. So it means that it's a different debugger. So you still need, so it has a RLPL debugger that is different from the debugger that you have in your gen application. One of the lack of features is stuff like that. So you can only see the X variable. You can see the N variable. So it has some limitations. So you still need to have the gen file, the debugger gen in your gen file. Run bundle 241. So now it has an option called Rust. to allow building gems with Rust extensions. Writing a Rust extension gem allows you to interact Ruby from Rust, the same as C extension gems like Nakogiri, PostgreSQL, MySQL, and others. So when you have the PG gem, it has some C extension languages where the C language communicates with Ruby. So we'll have the same thing with Rust now, but it's just a simple, raw implementation. So it's just the first version. So I believe you won't see any integration with Rust by now. So let's go to the language. So, Ruby is not changing much, to be honest. So you can expect any change in Ruby in the next year, I believe. So they introduced the data class. An immutable object is an object whose the state cannot be modified after it's created. So it is a class with immutated attributes. The objective was to build a data model on the principles of the value object introduced by Martin Fowler. So, the value objects is that concept like when you want to represent compound things. For example, 2D coordinates. So you'll have an X value and an Y value, or you want to represent a money that consists in a number and the currency symbol. So you usually use the value object. So it doesn't have nothing related to thread safety. When I saw this this feature on Ruby, that it was an immutable object, I thought about it because on Java, when this model of thread safety was implemented, we have this immutable approach to handle with the thread safety, but it doesn't have nothing to do with that. So it's just to represent the valid objects better. The class is similar to struct and partially shares an implementation, but has more lean and strict API. So the struct could represent that, but it had some, let's say, issues. So you could instantiate the struct here. Then you could put two values and put that data. But if you put it in an array, you'll have something like that, 10 and 10. But actually what you were expecting was something like that, an array of point objects, but it doesn't have. So the data class was introduced. So you can create a point object this way. Also, you can use key arguments. You can change the value with the with method. And then you can see the value was changed for 40. But you can do stuff like that because the Y property is immutable. So you can just set another value. Another thing was the anonymous arguments passing. So it's a new feature. So before Ruby 3.2, you should do things like that. So you had to put the name of the arguments. But now it can be anonymous, like that. You can before Ruby 3.2, you can use that on the method signatures, yeah, but not inside the methods. But now on Ruby 3.2, you can do that. Also, we had this feature that is not more in test. It's it's ready for production. So you can use pattern matching to find things. So let's suppose you have this rash with name John, and you have two friends, Alex and Don, and you want to find what is the age of Alex. So you can use, you couldn't use actually on Ruby 3.2 this kind of thing, but now on Ruby 3.2 you can use, oops, you can use this asterisks here and here, and you can get the 24 using pattern matching. And we have more changes. Stat is now built-in class, so you don't need to require in your Ruby file. Hash shift returns nil, even if there's a default block. So the default block doesn't work that way anymore. So you don't have a default value for shift anymore. Also, we have improved the abstract syntax tree. You know, this is the class used to create the syntax tree that I showed in other slides. So they are improving that to work better with the IDEs. So Ruby are working to improve the auto-completion in IDEs and also show errors while you are typing and stuff like that. So they improved this class for that. So some constants were removed. So fixed none, big none, and few others. So if you have these constants, you'll need to remove that from your application. Some methods were removed too. So dir exists, file exists, and few others. Actually, it was replaced for exist and file exist, just that. That's it. I believe I covered everything. That's it. This was what was introduced on Ruby 3.2 at all. Any question?
If anyone has a question, feel free to type it on the chat or raise your hand and we'll unmute you.
The slide is not available yet. I will share it later. I don't know how, but guys, if you have any question, I believe we have time. Yeah, it should be just a 30-minute presentation, but it's 10 minutes. Okay, I can share on LinkedIn.
Yeah, we'll have the whole video, like the whole recording of the presentation, up on our YouTube channel in a few days. So be sure to follow us on YouTube, on our social media. We show up as Koombea everywhere. So be sure to follow us, and we will be uploading the whole presentation there in a few days.
Okay. No question, guy. I would talk with someone. De nada.
It was a very clear explanation.
Maybe. I hope so.
Well, guys, thank you everyone for coming to these Koombea talks. Thank you, Lázaro, for the presentation and for preparing everything.
Okay.
Yeah.
Okay, I just want to talk about Koombea, that we have open positions. So if you want to be part of the team, so you can see our opportunities on the site and on the website. Actually, we don't have a Ruby position open right now, but they promised that we will have some open positions in the future. But we have another options there, like Node programming and other languages and many areas. So just submit your resume, and that's it.
Yeah, thank you everyone for joining, and we'll see you in the
Thanks.
next one. Bye
Okay,
everyone.
bye bye.